in a little bit more detail. As we get closer, you can see Mars's moons, Phobos and Deimos. There they are. And from this comet, it gets incredibly close to the planet Mars. Let's just see how close that is. Let's go and look at Mars. Let's go and zoom well out of the planet. And we can measure that distance as well. We can right-click on Mars, measure the distance from, and left-click on the comet. And you can see at this point, it's only 72,000 miles, an incredibly close flyby. It's going to be a spectacular thing to see from the surface of Mars, hopefully with our spacecraft in orbit around Mars and from the surface. And of course, comets aren't just something we look at from a long, long way away. Occasionally, we send spacecraft to go and take a slightly closer look at them. And if we go back to the present day, you'll see that this comet here, Churyumov-Gerasimenko, has a spacecraft very close to it, Rosetta. And right now, they're only a few million miles apart, in fact. You can see that distance, 16.6 million miles. But if I start fast-forwarding time to about 12 months from now, the Rosetta mission, which is a collaboration between the European Space Agency and NASA as well. If we go all the way through the beginning of next year, you're going to see that the Rosetta spacecraft gets incredibly close to this comet as well. And in fact, it's going to go into orbit around the comet and eventually put a lander onto the surface of that comet as well. And so now what we're going to do is just go back to our little QE2 module, so you can all at home, right on board the asteroid, see exactly where it is. Up in the top corner is the Tours and Features module. I'm going to hit 1998 QE2, and we take you to this little mini module just about QE2. And by hitting the ride-along button, there I am on board the asteroid. You can see the Earth and the Moon right behind it. For the kind of Bruce Willis view, bring up the controls and hit this kind of ride-along button here, and suddenly you're riding on board the asteroid as it does its flyby of the Earth over the next few days. So that's Eyes on the Solar System. Once again, you can go to it by going to eyes.nasa.gov. And with that, I'm going to throw it back to Gay.
Thanks, Doug. So you get to see it even though you don't see it in your own backyard. You can see it on the web. Paul Chodas is back with us. He's with the NEO Program Office. Let's kind of help people understand why asteroids are so important. There's a variety of reasons. It's not just the catastrophic fear factor.
These are some of the most primitive objects in the solar system. So they give us information, if we can study them, about how the solar system was formed. What were the ingredients that were in the nebula which formed the solar system? Some of the most primitive objects that we can use to study the early nebula of the solar system.
So we can learn about our own solar system. Are these things something that we would be interested in the future?
It's also surprising that there are hydrated minerals in some of these objects which were formed in the outer area, outer asteroid belt, so they didn't receive a lot of heating. And so it's possible that we could actually mine these objects. If we go out with some sort of, in the distant future possibly, or not so distant future, we could go out and extract things like water and oxygen from these and use them as resources in space, possibly. There are also many minerals that are present in these objects. And so it's possible that these things could be a source of resources and minerals that we could use on the Earth.
But seems the common person seems to be most interested about asteroids because of concerns of the safety of the planet. And your office has the job of tracking these asteroids. And we have a graphic of what we have seen in terms of numbers since May 8th. But you tell me that the numbers have already increased.
Yes, I think the number of near-Earth asteroids listed on the top there is up by at least 50 since May the 8th.
In less than a month.
In less than a month. Objects, near-Earth objects are discovered at the rate of something like 80 per month.
Wow.
And asteroids in general are discovered at something like 3,000 per month. And so the numbers are just exploding. We have 600,000 asteroids in our database right now for the entire list of asteroids.
But you seem to have a real handle on the larger ones, the ones that are over 1 kilometer, say.
Yes, those were the first priority of the Near-Earth Object Program Office. We wanted to know their orbits very accurately and the uncertainties, and we wanted to project them into the future. We wanted to know whether they could hit the Earth, especially. So we take the observations from the Minor Planet Center, located in Cambridge, Massachusetts. They collect worldwide observations. We use those then to compute high-precision orbits for these asteroids, and that's a complicated mathematical process, but it's very important. and then project those into the future and look at all possible possibilities. We take into account the gravity of the solar system. We go about 100 years into the future, so it's long on a human time scale, but on a solar system time scale, that's just a blink of the eye.
And that information is constantly changing because as we get more and more information, say the things that we're getting from radar today, all that changes the computation of the orbit.
Yes, so we will use the radar measurements that were made last night and will be made tomorrow. We'll use those to improve the orbit even better. In this case, we know this asteroid can't hit the Earth, but using the radar measurements, we'll be able to predict it accurately hundreds of years into the future.
And I would think that that information would be key if you are going to have a mission to an asteroid. You have to know exactly where it is at any given time.
Yes, the more observations we get, the better. Radar really helps to pin down the orbit of an asteroid, as well as setting up, as indicating the size of it. So we saw this morning those amazing images. That's the first time I've seen them, which Marina showed. That were very impressive. Now we know that the size, our estimates of the size was pretty accurate.
And it's a binary.
And a binary. Marina must have been really excited to see that. The binaries are not so common. So that was very exciting. I'm happy to see that. And we can get a good idea now of the mass of that asteroid if we track and know a little bit about the orbit of the secondary, the satellite, because the orbital period of the satellite is related to the mass of the asteroid.
All right, so the next mission to an asteroid is one to an asteroid called Bennu, and we have a picture of Bennu.
Yes, now Bennu is about half a kilometer, 500 meters in diameter. Actually, it's probably very similar in size to the satellite of QE2, come to think of it. The mission that will go to Bennu is called OSIRIS-REx. It's a very exciting mission to be launched in the year 2016.
We have visuals of that, in fact.
Let's see the visual.
There it is.
Here we are. Here we are arriving at the asteroid, and around the year 2018, after approximately a year of studying the asteroid at a distance, the spacecraft will deploy an arm and pick up samples from the surface of the asteroid, a certain number of grams. We'll put it into a return capsule, and then OSIRIS-REx will come back to the Earth, deploy that capsule, and it will land in the year 2023 in Utah.
Now,
and we'll have actual samples from that asteroid.
That is an incredibly ambitious endeavor.
It's very exciting.
But there is another one that is even more ambitious.
Yes. NASA has proposed an asteroid initiative with a very exciting goal of going out to find a nearer Earth asteroid, one that's in an orbit that's pretty close to the Earth. And we would send a spacecraft out there, a high-tech spacecraft, powered by solar arrays, deploy a bag around this asteroid. It has to be the right size here, about 20 to 30 feet in diameter. We'll deploy a bag, inflate it, and then move the spacecraft, match its orbital speed, the rotation speed, move the spacecraft around the asteroid, put it in the bag, and then cinch the bag, thus capturing the asteroid. Then we will actually have an entire asteroid, which we will have studied in detail at some distance, and we'll be able to study how the whole thing is constructed, what its bulk properties are. And this would be very useful information if we ever had to deflect an asteroid. We need to know things like the bulk properties and the density, that sort of thing. Here we see the asteroid being pulled into the space, close to the spacecraft, the advanced ion engines firing. We push the asteroid back towards the Earth, actually towards the Moon, and put it into orbit around the Moon, which is a stable place. Then the Orion spacecraft would launch with astronauts from Florida, and it could go up and visit the captured asteroid, which is in orbit around the Moon. They could use tools to actually take samples from the asteroid and take the most interesting samples from interesting areas on this asteroid. We put the samples then and return those to the Earth, and we could study them up close. It's a very exciting mission.
You personally have a role, a sort of a predecessor role to this mission, in that it's going to be your job to find us that asteroid.
Well, the Near Earth Object Program Office is charged with finding and selecting a good target. And we need to find one that matches certain constraints. It has to be about the right size, 20 to 30 feet. And especially, it has to be in an orbit that passes the Earth fairly slowly, so that the moon would have a chance of capturing it. So we are looking for very specific orbit types as well. And we have about a dozen candidates already, and we think we will find more good candidates in the next few years. So we'll be looking at all the discoveries, and searching for these asteroids will be a high priority in the next few years. But it's the same survey that will be searching for asteroids that could hit the Earth. So it's the same basic technique, but we'll be watching for those ones which are in orbits that could come close to the Earth very slowly and could be captured.
And you're discovering new ones every day, so you may be seeing one quite soon.
Yeah, every day, yes. But we'll be looking for just the right one. I think
right.
we'll find one in the next few years.
And timed just right to be where you want it just then.
We also need it to naturally come by the Earth at about the right time as well. That's right.
All right.
We'll find one.
As promised, we are doing some of the social media questions that you've sent in. We have one from Ted Wade. If Hubble is retired or replaced, can it be assigned to NEO search duties? That's an interesting question.
Well, a good question. Hubble is not well suited to search for asteroids. It's actually has a very narrow field of view and can take very detailed close-ups of particular objects. But what we need is to search large regions of the sky to find an object in which we don't know where it is. So we need to have a large field of view. So Hubble is not the appropriate instrument to find asteroids.
Well, we have Marina standing by as well. Both of you could help us with this. What do we know about 1998 QE2's composition, and what might we learn about it during this flyby? So both of you can probably help us with that. You know a little bit about the composition, you said.
We think we know basically what it looks like, yes, and that it's very dark, it's carbonaceous, and it very primitive elements coming from the outer solar system. But I was fascinated to see the craters on Marina's images. Very interesting. As I say, it would be great to learn about the density of this object from the orbital period of its satellite. Then we will know approximately. It give us a better idea of the composition.
I'll give this question also to Marina. The question is, what do we know about QE2's composition, and what might we learn during this flyby? And you and I talked a little bit earlier on. You said since it's dark, it may be larger than you thought it was. Do you still believe that's the case, that it's larger than you thought?
Sorry? I don't hear a thing.
Apparently, Marina
I hear
can't hear me.
dial
But there was a question at one point.
And I can hear Gail very, okay.
I think she can hear me
I can
now?
hear, yes,
okay,
I can hear
good.
you now.
Marina can hear me. Do you think that this asteroid is larger than you first anticipated it to be?
1998 QE2, it's about right size. So whatever, this was initially estimated by Spitzer Science Telescope. Based on Spitzer Science Telescope data, they estimated it has reflectivity about 6% and 2.7 kilometer diameter. So from what we can see from the visible extent of the radar images, it is about right.
Now, this is one radar observation, but you mentioned that you're going to be doing several others in the coming year. Is that correct?
Yeah, it is correct. What we do, this is basically, we always observe, well, last year was really busy. Let me tell you about last year. Last year, we observed 66 asteroids only at Arecibo, and we observed 28 asteroids at Goldstone. We spend like 400 hours observing asteroids only at Goldstone. So we have a very busy asteroid season ahead. We are probably expecting, again, probably 50 objects to be observed. Not everything is going to be glorious images, as you have seen. Some of them will be just a detection, but just as important because we can get their orbits right and maybe some initial physical characterization. But I think that the next good radar target is coming this summer. It's coming in August. It's asteroid 2005 WK4. And it's about 300 meters, as we think it's about 300 meters in diameter. So it is smaller than the satellite of 1998 QE2, which is about 600 meters in diameter. And this one is going to come relatively close, about 8 lunar distances, and so we expect to really have a very nice images. And then the next year, we are going to have a chance to observe a comet. So this is going to be comet Linear. It's 209P comet Linear in May of 2013.